Let's continue on with our lab demonstrations. This next lab says that it contains a cross-site scripting vulnerability in the search query tracking functionality. It uses the JavaScript document.write function, which writes data out to the page. The document.write function is called from location.search, which you can control using the website URL. To solve this lab, perform a cross-site scripting attack that calls the alert function. Once again, let's insert some script here and see how the website renders it. Immediately we can see that this vulnerability does not work as it did last time. Let's use inspect and see how the website is rendering this. Do you remember in 002 when I said that it seemed like the website was going out of its way to render our script input? This looks more like what I'd expect to see from this user input. Maybe we can view page source and see why that script tag isn't rendering. Here we go. As we can see, our less than greater than signs are being escaped in the code. This means that the website has protections against using these characters in user input. This is a way for the website to tell the browser that we need to put a less than sign here, but I'm not trying to give you HTML content. I need you to treat this as the character less than, not as some sort of HTML browser thing. It is encoding these special characters. The lab also told us that we were supposed to look at document.write to figure out what might be vulnerable in this code. Let's look at that. Here we go. Document.write is a JavaScript function that creates HTML content on the page. In this case, document.write is trying to put an image based on our search term down here. We can see that this new image tag contains our search term directly. And then open up another script tag after that, right about here. Let's try that out. This, in our search term, is duplicating this, which is legitimate in the image tag. Close the quote for the source, and close the HTML bracket. Now, when document.write creates this image source tag has been closed at this point. Boom, there you go. And just as I suspected, our search term closed this image tag, wrote our script, and then the website ended up with these extra terms, which had been attached to this, that it didn't know what to do with, so it just rendered them as text. This close quote and close HTML bracket is not the ones that we put in. The ones that we put in are right here in front of our script. These are the ones that were legitimately generated by this image tag by document.write. However, because we had already closed our image tag, the website didn't know what to do with them. So the website just slaps them here and thinks that it's normal text trying to be rendered on the page. To relate it back to 003, this search box was the source and this document.write was the sink. Now moving on to the next lab. This one says that it contains a vulnerability in the search blog functionality again. This time it uses the inner HTML assignment, which changes the HTML contents of a div element using data from location.search. Again, we must create a cross-site scripting attack that calls the alert function. Once again, let's try our standard input. That didn't work. Let's use inspect to see what's happening. Using the inspect, it looks like our script tags should be rendered perfectly. I mean, here it is, clear as day. What gives? Well, if we consult this documentation about HTML5 from w3.org, we can see right here it says that script elements inserted using inner HTML do not execute when they are inserted. This makes a lot of sense from a safety perspective, but gives us a headache as attackers. Well, if script tags aren't going to work, what can we do? Fortunately, we have another trick up our sleeve. We're going to try to get the website to write an image tag for us. And when the source is found to be invalid, we're going to give it something to do on error. Aha, there we go. Let's see how that rendered in the page that made this work. Right there where our script tag was before, that didn't render because HTML5 does not render script tags using inner HTML, we were able to insert an image tag. You can see here that the image is trying to render, but the source is invalid. So when it gets this, it throws an error. And then we told it, if there's an error, we want you to alert. And that's exactly what we needed it to do to solve the lab. We've worked with this a little bit in our videos 001 and 003, But just to prove a point, let's see what happens if I try to get it to do an onMouseOver event instead of an onError event. We haven't gotten our alert yet. I wonder how we could trigger it. Ah, there it is, onMouseOver. Similarly, we can do the same with onClick. These labs were a little bit more complicated, and the website had some basic protections against cross-site scripting. First of all, they encoded our input, so we couldn't just throw less than, greater than signs around willy-nilly. Secondly, it involved a little bit more complicated thought around closing other tags to get our script tag to stand alone. And lastly, HTML5 had protections. They knew that we might try to inject script tags, so they said, we're not going to render any script that is injected using the inner HTML functionality. Unfortunately, we were still able to get around this by getting an alert to render another way, i.e. with a broken image tag. That's all for this episode. Thanks for watching.